Welcome to another presentation on the logic gates. First of all, we have to define what logic gates are all about. Extracting from here, the definition for logic gates or logic elements is logic gates are simple elements which, when networked together, they form a logic circuit that can process and respond to digital signal inputs. They give binary output signals in response to one or more input signals. Each element or gate operates in a different way. Digital processors consist of thousands of logic gates and can perform bit manipulation easily and quickly using three basic logic gates: the AND gate, OR gate, and NOT gate. So these are the three gate elements that I would want to explain. We want to have a good appreciation of how the computer carries out its processing function. Basically, the three basic arrangements that you will find in a computer processor are the AND gate, the OR gate, and the NOT gate. The gate elements receive inputs that they will process to produce outputs. Typical inputs on the motor vehicle, they come from sensors. Then typical outputs on motor vehicle system, they go to actuators, and the typical actuators that we have on the motor vehicle in the engine management system, for instance, are the coil packs and injectors. Most probably the idle control actuators, the typical actuator which receives output from the computer. Now, starting with the AND gate. The AND gate is an arrangement whereby two inputs are supplied to a circuit, to an electronic circuit, or to a gate element as we call it, and those two inputs are supposed to produce a typical output, a pre-programmed output. But in this arrangement, on the AND gate requires that both inputs A and B be at logic 1, logic level 1, or be switched on at the same time for us to retain an output which is switched on or which is at logic level 1. So in this case, this sort of arrangement is equated to an electric circuit where we've got two switches which are connected in series. It's shown in this diagram. The requirement is for the light to come on, we should have both switches activated to the on position. And the switches here represent the two inputs, the lamp represents the output. So what it means is we need both A and B at the same time in order for us to switch on output at X. Below is what we refer to as a truth table, which shows the combinations of the scenarios that are likely to combinations of inputs and outputs. The typical combinations of inputs and outputs with respect to the AND gate. When input A and B are both off or at logic 0, also means that the output at X will be off or at logic 0. When the input at A is at 0, but input at B is at 1, that is, it is on, the output at X will be off, because this kind of arrangement requires both inputs A and B to be on at the same time for us to have the output at X. When the input at A is at 1 and the input at B is at 0, the output at X will be 0. We only have a live output at X when both A and B are on.